inside every atom lies a force powerful enough to change the world. A force hidden inside matter itself. For decades, scientists could only imagine what that invisible energy might mean, because the atom was still largely a mystery. Then came a breakthrough. Scientists discovered that certain atomic nuclei could split, releasing enormous amounts of energy in the process. And something even more remarkable was possible. One splitting nucleus could release neutrons, triggering more reactions, and then even more. Suddenly, the question changed. It was no longer simply whether a chain reaction could happen. Could humans actually control it? In 1942, a team of scientists began an extraordinary experiment beneath a stadium in Chicago, working with primitive equipment. Their machine looked nothing like a modern reactor. It was a huge structure built from graphite blocks, wood, metal, and instruments. Then the controls were adjusted. Slowly, the readings changed. The reaction was becoming stronger, but it was still under control. On December 2nd, the experiment reached a historic moment. The first controlled, self-sustaining nuclear chain reaction in human history. Humanity had learned to control the chain reaction. But another question remained. Could this incredible power be used for peace? Instead of allowing nuclear energy to end with destruction, scientists began imagining something very different. Heat converted into useful power. The idea was simple in principle. Use controlled nuclear energy to create heat, produce steam, drive turbines, and generate electricity. 12 years after the Chicago experiment, that vision became reality. A new nuclear power station was rising at Obninsk. On June 26, 1954, electricity generated by the reactor was connected to the power grid, marking a new era. The atom was no longer only a symbol of terrifying power. It had become a source of controlled energy for society. And nuclear technology found other peaceful uses too, from medical treatments and diagnosis to scientific research and industrial applications. Yet the discovery came with a lesson that remains important today. Extraordinary power demands extraordinary responsibility, precision, and care. We did not simply discover the power inside the atom. We learned to control it, and that changed the world.